Yes, we're recording. Right. So question 2. A particle P is projected vertically upwards and reaches its greatest height half a second after the instant of projection. Calculate the speed of projection of P. Well, let's set up our Suvati kind of stuff. So we've got we've got an initial speed which we're trying to find out. It reaches its greatest height. So what has happened when it reaches its greatest height to its velocity? It is momentarily 0. So that's a v like that to that. V is 0. It does this after a time of 0.5 seconds. And the acceleration, what we have going on through all of this, is an acceleration of minus 9.8, because I am going to take upwards as being positive, because that seems sensible. So what connects U, V, T and A? This is where you tell me the equation. Yeah. Nice, easy, 2 marks to start with. 0 is U minus 9.8 times a half, giving us U equals 4.9 metres per second. What a great 2 marks to begin with. We're laughing about that. Find the greatest height of P above the point of projection. So point 2, we're now going to use some of this information again, and we can use whatever we want. I think we can always try and do this without using a value we've already found, but I think we're pretty confident we've got the right value there. So shall we use that, because we've got, it seems sensible to use U as being 4.9, V is 0, A is minus 9.8, and we want to find S, and S is the height above the point of projection. So this is going to be V squared is U squared plus 2AS. Of course, we could have used S equals, what would it need to be? It would be the VT minus a half AT squared. Actually, that makes an even simpler calculation, doesn't it? I don't know why I'm using this one. But anyway, we've got 0 is 4.9 squared minus 2 times 9.8 times S, which, if we rearrange it, we're going to get what we're going to get. 4.9 squared divided by 2 times 9.8 gives us 1.125, 225, sorry. 1.225 metres. There we go. Which we probably ought to give to 3 significant figures, but that's the full version, so let's leave it exact like that. It is given that the point of projection is actually 0.539 metres above the ground. Why that number? Find the speed of P immediately before it strikes the ground. Okay? Again, we have a variety of approaches we could take for this. What should we do? I can think of a number of different ways we could go about doing this. Okay, well, the one that pops into my head first says let's just consider the whole motion down from that greatest height to when it strikes the ground and see what's going on with that. Because that means we're starting with a velocity of 0. We're going to take downwards as being positive this time. We've got an acceleration of 9.8. We've got a distance travelled of 1.225 plus 0.539. And we want to find the velocity with which it strikes the ground, so we want V. So this figure here is whatever that is. That is 1.764. So we're going to use again V squared is U squared plus 2AS. So we're going to have V squared is 0 plus 2 times 9.8 times 1.764. And V is the square root of that. So I'm going to do the square root of 2 times 10.8 plus 1.764, which gives me an answer of 5.88 meters per second. There we go. Okay, other approaches, other things that we could have done to get this same answer. Well, we could have said, actually, if it was projected at 4.9, then by the time it comes back down, its velocity would be 4.9, wouldn't it, in the opposite direction? So we could talk about it having an initial velocity of 4.9 over a distance of 0.539 and find its final velocity that way using the same equation and do that calculation. That struck me as being one option that we could do as well. Right, are we happy? We've just got another load of marks. 8, so we've got 14 marks so far, so that's pushing 20%, isn't it? Haha! Oh, that's maths.